Welcome to the Bytecode. I'm Rosh Shafu, and today's episode is with Alex, who wrote this really interesting tool to automatically generate solidity tests based on the BTT technique, which is the branching tree technique introduced by Paul. So really excited about this. Alex, thanks for taking the time.
Yeah, of course. Thank you for having me.
For sure, man, for sure. So, yeah, briefly introduce yourself, introduce BTT, and then walk us through the tool and the implementation.
Yeah, of course. So, hi everyone. I'm Alex. I'm a dev at OpenZeppelin. And yeah, I'm the author of Bulloak. So yeah, we'll be talking about what it is, and a bit about the branching tree technique, and then yeah, just diving into the code. So cool. So first, yeah, what is the BTT, right? So it's a thing that Paul, let me zoom in. Paul, who is a co-founder of Sadler, um, he created this kind of like testing practice to, make sure that you test everything that you need to. And what it is basically you have a tree file. So this thing here, is an example. You have just a tree. Um, and then you consider all possible execution paths. So if you have a function like, for example, I don't know, hash pair in the OpenZeppelin contracts, you create a spec, which is just this tree, where you consider every single possible execution path. So maybe something like symbolic execution, right? And then you kind of create your tests and order them in a way that it follows the spec, right? So basically, your tests emulate the spec and make sure that everything is covered. So there's some benefits to it, right? And yeah, it seems like a few people liked it, right? Like the practice, and yeah. So there's also this talk by Paul explaining the BDD stuff to a crowd of people at ETCC. And I saw this talk, I watched it, and yeah, I got inspired, right? I thought, yeah, this is awesome. This is a great side project, and I decided to just automate it, right? So yeah, that's where bulloak comes in, right? So it's basically the same practice that Paul described, but automated. So you have a little CLI2 tool to just generate these tests from a spec. So, well, first of all, the name. I know it's a bit weird, right? I'm not a native English speaker, so I don't really know how would you pronounce it. But yeah, I just say bullock. And the name comes from the hardest wood, right? So solidity, and then a tree, so a solid tree, and then you have hardwood. So that's basically it. Um, and
Okay.
yeah, yeah, basically, Bullock has two main features, right? It has a scaffold command and then a check command. Scaffold is the one you use for generating, Solidity code, the tests from a tree. And then check is basically once you have some tests and a tree, and you make some changes to either one of them, you can use check to, you know, kind of check if there's like differences or whatever. So those are the main two things that Bullock does. You can read the whole README. It's basically all the documentation that we have right now. Possibly in the future we'll have a website for it. So this, in addition to Paul's talk, should be enough to know everything about it. So yeah, do you have any questions at all? If not, we can just jump into the code. Cool. So let me make this bigger. Yeah.
Yeah, maybe Alex,
And
just to
actually, let me know.
summarize, just to summarize,
Yeah.
because
Yeah.
I really like BTT, and like I really think it's super intuitive. Like I think before we Paul basically put in the formalism for this, you kind of did this already, right? You kind like you tried, okay, what
Right.
are all possible state transitions, and you basically are testing for this. But what Paul basically did is like this formalism, right? How to actually write this down in a tree structure and so on and so forth, which is really cool and actually kind of funny. Like I had Paul on the bytecode. I don't know if it was before you wrote this or after, but we looked at some tree files and I was like, damn, someone has to automate this. But I'm not
Right.
100% sure about the timeline. But yeah, it's just funny.
Yeah. I mean, so this project came to life in August last year. So I don't know. I just watched the ECC talk and I just said, yeah, this is a great thing to have and just set out to do it. So yeah, that's it. So yeah, probably yeah, Paul had the idea before, and actually I think it's on the slide, right? Yeah, so it's potentially automatable. So yeah, I just
Mm,
took inspiration from that. Um,
yeah,
and yeah, you're right.
awesome.
So this is an example from observability contracts. Uh, and if you squint a bit, yeah, it's basically the same practice, right? Um, you just go in a tree of like descriptions, and then leaves are the actual tests, right? So it's basically yeah, what you would do
Mm,
if you were to go over every single execution path. So yeah, it's good to have a format for it and an established practice. So yeah, cool. Yeah. So so bulloak is basically just a Rust project. It's a crate, right? You can install it with cargo install bulk. It'll just take care of everything. And basically, it's a CLI command, right? So you would do something like bulloak. Let me know if you can see the screen. I'm not sure if I can make it bigger. It seems I cannot. But you would basically do something like this, right?
yeah,
You would
looks
do bulloak. Yeah.
looks good. Looks good. Maybe zoom in a little bit more, but
Okay.
other than that, it looks good.
I don't think I can. Word doesn't let me for some reason. Soon. No.
Okay, then
I
it's
don't know.
fine. That's
Should
fine.
have taken care of that before, but yeah. But yeah, this is basically how you use it. You have a scaffold command, and then you pass some files. Uh, you do help. You have the different commands and help on them. And basically, yeah, it's a crate, as any other Rust crate. It has a library file, and then it has a main. In this case, we have a main because yeah, it's a CLI tool, so it's a binary as well. But yeah, you can use it also as a library. I don't think many people use it that way. But yeah, if you want to build something on top of bulloak, you can. You can just add it to your project. And yeah, so bulloak, so it's basically a compiler. Um, it's a very tiny one, but it is a compiler, right? It takes a tree and it outputs a test file, right? A Foundry test contract. And it goes through different passes. It starts by parsing, so it gives you out an AST, and then it makes some transformations and gives you a high level intermediate representation. And then after that, it emits the Foundry code, right? The Solidity code. So you can see that here, right? So we got per tree, cluster, which is just a simple tree that describes a function. And then with bulloak, you can generate the corresponding solidity. And this is a short example, but you could imagine in a case where it's a very complex function and you have like a very deep tree. It could be cumbersome to have all of this boilerplate written by you, right? So bulloak comes in handy for that, right? This is basically the first thing that bulloak fixes. All this boilerplate. So yeah, and like I said, it's a compiler, and hopefully it's clearing the code, right? There's separate phases, right? Syntax, HIR, and so, and then scaffold and check are the actual, things that put those phases together. So if we come to the scaffold module, you can see here, it's a very standard clap interface. We just derive parser, and then we have some flags that we pass to the command. And yeah, we just run it. And it does what you would expect, right? It takes every single file, it just reads it, passes it through the compiler, and it outputs the Solidity file. So we just write it. Very standard, nothing really crazy. Standard compiler. Sorry, let me. And yeah, a nice thing about bulloak is that whenever you have something that's not well written, in the sense that there's certain rules to a tree, and bullock helps you enforce them, right? When you have a missing character, or when you're using when where it shouldn't be, yeah, bullock tells you all of that, and it points to the place where it happens. So there's a few rules. You can check them out later, but yeah, they're basically just making sure that we can actually output some tests. So yeah, to continue.
Yeah, Alex, this is actually interesting. Like what are the rules? What are the allowed keywords? What do the keywords actually do?
Right. So yeah, let me think how to better explain this. So if we go to the example made by Paul, you can see here that every single sentence starts with one of three words, right? When, given, or it. So this is just kind of a equivalence between these keywords and then what they should look like in Solidity. So leaves should always start with like it, and this just represents that this will be compared to a test. And then when and given are separate keywords that define different things. So for example here, given and when, this is how Paul defines them, right? One is for state and one is for parameters. And this was actually a discussion that happened after bulloak was alive. And it's basically, it's not that easy to keep in mind when automating this, whether something is going to be like state or a parameter. So this is all responsibility of the developer to keep in mind and make the proper like when or given. So from bullock's standpoint, so from bullock's point of view, when and given are the same, so they don't matter. So this is something to keep in mind actually. But yeah, that's basically it. You have three keywords then you can use, and then if you use them, if a sentence does not start with when, then a error, and bullock will show you where it happened. I don't know if the example is that exact one. Yeah. So, for example, we also support action items, action descriptions. So I have an example. I don't have an example right now. But yeah, let's just show you the AST, right? So you can have the root, which is basically just this, right? The name of the contract. And then you have conditions, which are when or given nodes. You have actions, which are it nodes. So anything that starts with it. And this should be like leaves. And I say this one and not this one because these are just basically comments. So if you look at the output, you can see here. So for this tree, you have it should never revert, which is this one, this test here. And then you have a condition when the first arc is smaller than the second arc, and a corresponding test, which is this one. So you can see here the condition translates to this, and then the test, the it, which is the action, is just translated to a comment. In the future, there's gonna be more stuff. For example, there's someone actually working right now on adding VM skip. So it would look like this. And yeah, you can have other things. But yeah, this is basically what you'll have. And actually, this one is better. So you can imagine when you have multiple conditions, and it starts to stack. Every single condition that's not the last one, a parent of an action, is gonna be converted to a modifier and then added to as a modifier to the function, to the testing function. And this is also covered by Paul, right? All of these, if they are like not parents of a leaf, they will be converted to a modifier. And this is cool because this allows you to kind of stagger state whenever you need. So this branch kind of states a condition that you have to provide to the test, and the modifier makes sure that you actually have that condition when you run the test. So yeah, it gets a bit more complex, but yeah, bulloak takes care of all of this for you, and you only need to care about the actual spec. So yeah, and then I think that's all there is to the actual trees. You have roots, condition, actions, and action descriptions. And these are, like I said, these are just comments, right? And you can we actually support comments as well in the tree. So this will be converted to a comment, but in the tree itself, you can actually add comments. That'll work fine. So yeah, do you have any questions?
No, what I really liked, Alex, where you said, okay, this is basically a compiler, and you're totally right. Like the tree file is basically its own programming language, and yeah, and your tool is a compiler, which is a very good way of thinking about it. Like I played around yesterday, and I've never done any tree files before, and there was like, damn, why I'm getting a syntax error? You know, why is this keyword not allowed? And yeah, because it's basically like a programming language, and I'm using the wrong syntax. So yeah, good way of thinking
Right.
about it.
Yeah.
Just one question, like why
Yeah.
was it really necessary to write your own lexer and stuff like that? Like why not use like automatic like compiler infrastructure?
Right. So the idea is there's two answers. Well, two reasons. So the first one is, this is a side project of mine, right? So
Yeah,
I didn't
yeah,
wanna
no.
I didn't wanna, use a canon
Yeah, yeah,
for
yeah.
for this, uh, and I also wanted to, just try and do it in this way. I really like compilers, so I wanted to write it myself. And to be honest, this is, so I say compiler, but this is a bit of a overstatement, right? This is very, very simple syntax. Um, and the semantic pass. So the semantic analysis you do is very, very, very small. So yeah, it's an overstatement, but in the end it is, right? Even though it's a small one, it is a compiler, because yeah, we do care about syntax, we do care about a bit of semantics, and we do have like different phases, and yeah. And the second reason is, so I wanted to make it as easy as possible for people to contribute. And for example, if you look at Solidity parser, which we were going to talk about a bit later, they use this LALR pop. So this is just theory, compiler theory. But basically, this is a thing that lets you define the rules of your language, and then it generates the parser for you. So
Mm.
I didn't want to do this. I wanted to write it myself. And also, when someone comes here and tries to, extend the Solon parser, they have to know some of this stuff, and this is a bit of theory heavy. So I just wanted to make it easier for everyone to contribute. So yeah, those are my reasons. But yeah, it totally makes sense to also
Totally,
use
man. No,
when it's
man,
a
makes
yeah.
sense, makes sense. And I really like your implementation. It's a really clean implementation. That's
I tried to make it
very nice.
yeah. So well, I mean, the actual so it's basically based on an implementation by Burnt Sushi, um, which is like Andrew Gallant. This is the wait, not this one. This one. So this is the official regex implementation of the Rust language. And yeah, I read the code base a few years ago, and it's very, very, very good.
Hmm.
And basically, my parser is kind of based on his, so it's pretty similar. Um, I just wanted to, yeah, give it a wink, because it's a very good implementation and very clean. So I tried to
Yeah,
yeah, uh,
maybe
be
another
clean as well.
inspiration.
Have a
I really like the Huff compiler. I really like the Huff compiler. So maybe it would
uh,
be,
I've
yeah.
never I've actually never read it, so I don't really know much about Huff. But yeah, it probably is. Um, oh, it's a
Yeah, I really
single
like
read.
the implementation. Yeah, it's a very, very clean implementation.
Yeah, yeah, it looks. Yeah, I mean, yeah, I mean Rust. I have to say, it looks pretty clean. But yeah, cool. So that's basically scaffold. I don't think I'm missing anything. So yeah, basically a compiler that takes a tree and outputs a contract, a testing contract with some functions, and that's basically scaffold. Then check, it's a bit of a different beast, and it's also the more complex part of the project. So basically, what check does is it also compiles, but instead of emitting to a file here, it actually converts the high-level intermediate representation that I created to a parse tree from Solon parser. So basically this is just the definition of the parse tree that they use. Well, for people that don't know, Solon parser is, well, a parser. And it's a very complete implementation. It's compatible with Solana and Polkadot. It's very nice. It has everything you would need. So yeah, I decided that. Oh, and it's also what the Paradigm team uses in Foundry. So Foundry uses Solon parser. And yeah, I decided it made sense to also use it. And then, so I convert the HIR to a parse tree. And then I also use Solon parser to parse the existing .t.sol. And then I diff those parse trees. And this is because this way I have an easy way to then, after diffing them and knowing what the difference are, I can easily fix them, right? I can just mutate the parse tree and generate the corresponding Solidity code. So it's a bit more confusing, but basically we just compile it twice, make sure the outputs are the same. If they're not, yeah, then you'll see the errors. And the errors basically look like this. Something like this. So basically, you'll see, yeah, this function is missing. You can fix it by running this. And yeah, that place where the warning happened. So yeah, pretty simple, right? Let me actually run it. So in this case, you can see here that for this tree, we have this Solidity. And if we actually run bulloak again, you'll see that there's 3 functions here, right? But then this Solidity file has only 2. So yeah, and it makes sense, right? If you see the spec, there's 1, 2, and 3, right? There's 3 actions, so it should probably have, well, it should have 3 different tests. And if we run bulloak check, it tells us, right? Yeah, hey, there's this issue. You're missing a function, and you should probably fix it with, bulloak check. And if we do run it, then you can see in the diff. You can see in the diff that this function was added, and it's here, right? So it basically just, automates making sure your tests stay up to date with your spec. So that's what bulloak is doing, and it's quite. I have to say, yeah, it's a bit of a journey. This part of the code base. I actually commented it quite heavily because, yeah, for example, if you look at this part, yeah, it has quite a lot of comments, because yeah, I'm anticipating people contributing and yeah, being thankful. So yeah, so check is basically a command the same way scaffold is, we just derive parser from clap, which is just the standard way of creating CLI tools in Rust. And it has a few arguments, the ones you'd expect, the files, whether to fix it or whether to just output it to the console. And then, yeah, we just run it. And if we want to fix it, we fix them. and if not, just print them to the console. So yeah, I think that's it. I don't really want to get into it because it's quite the overhead, but yeah, the all of it. So yeah, those are the things: scaffolding, and then keeping your spec up to date with your tests. So bulloak hopefully helps you with that. So as an example, I wanted to show the Savior codebase, which sorry. So Paul is a co-founder of Savior, right? And then they obviously use trees and the corresponding Solidity tests. So bulloak runs. They have a lot of.
Yeah, Alex, you're still sharing your
They
GitHub
have a lot
if
of.
you. Oh, okay. Now we see your terminal. Okay.
Do you see my terminal?
Yes,
Oh,
yes.
okay.
Okay.
It's yeah, cool. So basically, we're running bulloak on all of Saviour's code base, and you can see we could not scaffold 11 files, and the reason is there's a rule that I implemented in bulloak that does not let you have two branches, like two conditions that are exactly the same. So you cannot have dupes. And this is because the reason is so these conditions are converted to tests, so function names in Solidity. So you will have two functions with the same name and the same arguments, right? So this would be an error in Solidity. So I decided to just error from beforehand, right? And like when scaffolding instead of when running the test itself. And yeah, in the future, this could be just a flag. We just allow this and then just name the functions something else, like appending a one or whatever. But you can see that, yeah, we do for every other file, we generate them. And yeah, it's very close to being what, to being able to be run in the Sabre code base. But yeah, I think that's all I have. So yeah,
Nice, Alex.
that's
Nice.
basically.
No, this
Do you have any
was
other
a great
questions? Any
overview.
thoughts?
Was a very great overview. It was very interesting to see how you implemented the check. Quite interesting.
Yeah.
Could you show the diagram? Could you share the diagram? Yeah.
Yeah.
Yes.
Yeah. It's a bit of a. It's a bit of a. a thing. Yeah.
It's a little
Um.
hacky, but if it works, it works.
Yeah.
It's nice.
Yeah. I mean. Yeah. I mean, I could. Yeah. The ideal way to create a parser for Solidity, but yeah. I mean, that's a heavy lift, and yeah.
Yes.
But yeah. I
Awesome,
mean,
man.
hopefully,
Listen, Alex,
hopefully,
yeah,
yeah. Just saying that. Yeah. Hopefully, it's easy to contribute, and yeah, that's actually to first stage issues that people can take, or the harder ones if they want. So yeah, cool.
awesome. Yeah, Alex,
Uh,
thanks for the overview. The GitHub link is going to be the first one in the description down below. So if you want to contribute, feel free to do so. Alex, thank you very much. I'm gonna put
Thank you for.
the Paul's video, Paul's tweet, Paul's video in the description down below as well. Your Twitter, obviously the GitHub, and yeah, I think that's it. Alex, thanks for taking the time, man. Thank you very much.
Thank you, man. Thank you. Well, see
Awesome.
ya. Bye bye.
See you in the next one, guys. Bye bye.